Okay, dear students, let us see what is there in this question. Now, two conductors S and T have VA characteristic graphs as shown below, and the graph is on your screen. Now, when the conductors are placed in a circuit below, the reading of the ammeter is 6 amperes. And what is the EMF of the cell? So this EMF is basically unknown, and we want to find E. And there are two conductors, and they're arranged in parallels, and the total current that is flowing through this branch is 6 ampere. The reading of the ammeter is 6 ampere, so it must pertain to the total current that is moving in the circuit. Anyways, so what is the EMF? We have to use the graph for this, and you try to see that because these two conductors S and T both are in parallel, it means that the potential difference across both of these conductors will come out to be equal to each other. Now, if we read this graph, the potential, like if it is equal, so the currents are different. Like for example, if I choose this value, so let us say the potential across them is 2 and 2, but the current in both of the cases will be different. So if it says that the potential should be same, it can have any value. It can have 2, it can have 5 for that sake. So let us say this value and this value. So one conductor will be having current 6 ampere, another will be having like nearly 3.5 or something. Now, how are we going to think now? So if, let us call this point as P. Now if we take that the voltage is more than this point, like we are in that region, so you see whatever be the current, like let us say call this as I1 and this as I2, the sum of I1 and I2 will definitely be more than 6. Why? Because at this point it is 3, so 3 plus 3 is 6. And if we are having more voltage than 4, like 4.5, 5, 5.5 or 6, then whatever be the value, like here you are having like nearly 3.75, but this value is 6, so the total is 9.75. It means you are having a current which is more than 6 ampere. So it cannot be, the voltage cannot be more than 4, so this region is out of question now. Similarly, if we talk about the other region, like this region where the value is lesser than 4, if we consider, let us say we are considering this 2. So this current is like 1.75 and this current is like 1.5. This current is like 0.75. The total of this current is lesser than 6. Always. Always the total will be lesser than 6. It means this condition is again violated if the battery is lesser than 4 volt. So there is only one option left, and that is that the battery should be equal to 4 volt. Now let us try, is it correct or not? If the battery is 4 volt, what is the current in both of the conductors? So both of the conductors are having 3 ampere current each. So 3 ampere goes into this, 3 ampere goes into this, and both of them are having the same potential equal to each other, that is the 4 volt. And also the total current in the ammeter will be equal to 6 in that case. So particularly for that value, we are having favorable conditions. Otherwise these conditions are not possible. So 5 is wrong, 8 is wrong, 13 is wrong, and the answer is 4 volts. So this is the correct explanation for this question. Okay, so my dear students, this is Professor Varun. If you have any further doubt in particular to this question or in this topic, you can message me in the comment section. Please subscribe to the YouTube channel. Share that YouTube channel with all your friends. All the best.